All right, we are looking at knowledge check 20.3.8. And for this, we're going to use tidyverse packages, but we're going to use data from the Ames housing package. So this is the Ames data. So if we take a look at this, we can see we have 81 different variables with almost 3,000 observations. Okay, so one of these variables is a variable called GR live area. So this is basically the above ground living square footage. So number one asks us assess the distribution of the square footage across a home sold. So let's go ahead, and to start off doing this, we can do, we're going to look at GR live area, and we can just do a basic histogram, and that'll give us a good idea of the distribution. Now we see histogram, it is informative in that it allows us to kind of see the bulk of the square footage in homes is somewhere in that 1,000 to 2,000 square feet, and then it kind of dwindles down to 3,000. Then we have some of these outliers that are above 4,000. We even have a couple above 5,000. Well, maybe to get a little bit more finer details in this histogram, we can always use bin width. And so when we think about square footage, maybe about 100 square feet is a good value to look at for the dispersion. And we start seeing a little bit more details here. We've got a little peak here, just over 1,000, and we got another peak here that is somewhere, that might be right around 1,500. We could even get more finely detailed with square footage across basically binning it in buckets of 50 square feet. And we can see now we have definite little peaks along the way where it seems to be some common square footage values. All right, we can get more information on this. And what we can do is we can actually take Ames, and we're going to go ahead and count. And what we're going to count is, first we're going to cut up the values of our GR live area variable, and we're going to do that in buckets of 50 square feet. And then we can follow this up with a range descending order. And now we see these bins here, bins of values, aligned to the bins that we have in this histogram. So we can see the greatest bin, or the largest bin, most common bin, is between 1,480 square feet and 1,520. So right around 1,500 square feet. And we can see that right here, this peak right here, that aligns or is associated with this bin here. The next largest bin is this 1,320 square feet to 1,380. So that's probably right around about 1,350 square feet. And then the next one is about 1,650 square feet. So that allows us to kind of see what are the most common square footages across the homes. There is a question here, do there appear to be some outliers in this feature? And we do. We definitely see some outliers that are likely above 4,000 square feet. What we could actually do is we could do geom box plot. And this will show us that actually the outliers start even before 3,000 square feet. So we have several homes that have outliers basically from the upper maybe 2,750 square feet and beyond. All right, so let's jump down to number 2 here. Assess the distribution, the age of homes. All right, so there is a variable within here that is year built. So we can go ahead and even look at year built. And so we can see that we have values going all the way back to 1872. But let's go ahead and range this in descending order by N. And here we see that most homes were built basically between 2005 and 2007. So 2005 is definitely the most common year of the homes that we have in our data set. Now we can go ahead and let's do some plotting here. ggplot, and we want to look at year built. And let's do a histogram. And here we can see our distribution. We definitely have a skewed distribution. And let's just do, what I'm going to do is bin width. And I want to do every 5 years. So now we can see that we have kind of this growing distribution where we have kind of a chunk of homes that are pretty common in the that would probably be 1925-ish. And then we have another big chunk of around 1960 to 1975. And then we see this big growth in the early 2000s. So is this feature normally distributed or is it skewed? Well, it's definitely not normally distributed, and it's definitely got a skewed distribution. Skewed left is what we would say there. And do there appear to be some outliers? Yes, and we can actually check to see with the geom box plot. And we see that our outliers are actually in the lower end. So we got some homes that are built in the 1800s, and that roughly looks to be around where our outliers begin, somewhere in that mid to late 1800s time frame. All right, last one here is assess the overall qual of homes sold. So we can look at Ames, and we have, let's go ahead and just count overall qual. And we can see we have homes that are built anywhere from very poor to very excellent. And we can see that the bulk of our homes look like fall around the average, above average quality. It says what percentage of homes fall in each of these quality levels. Well, we could actually do this by following up this count with mutate, and I want to create a percentage, and this is going to be n divided by the sum of n. And now we see we actually have 28% of our homes fall in the average quality, 25% fall in the above average, 20% fall in good, and so on.